Hi everyone, welcome to Study with Akshay, and this is Akshay. In this video, we are basically going to start Physics 10th ICSE first chapter, that is force. In that first set, moment of force and equilibrium will be taught in this video. So complete detailed explanation regarding the moment of force and equilibrium will be given in this video. If you guys have not subscribed to the channel, please do subscribe and click on the bell icon so that you'll get regular notification. So why to waste time? Let's start. So force, that what is the chapter name? Force. What is this force? Force when applied on a rigid body can only cause motion in it, while when applied on a non-rigid body can cause both a change in its size or shape and motion in it. So I shall explain this in a detailed manner. So rigid body means when you apply force on it. So like on the table, if you apply force towards one direction from left to right, imagine if you apply force, the table will move. So there is only motion created, but the shape or size of the table is not changing. So that is an example for a rigid body. And for a non-rigid body, chapati dough. When you are doing the chapati dough, when you put force on the chapati dough, it changes its shape as well as the size, and also motion is created along with it. Similar way with clay. So that, those are considered as a non-rigid body. Okay, next. Force is therefore a vector quantity. Okay, we all have learned this from past 2 years. Basically, in 8th and 9th also we have learned force is a vector quantity. So SI unit of force is Newton, and or it is also a few times considered as kgf, kilogram force. Both can be used, but basically standard SI unit is Newton. So CGS unit is dyne. Remember, there is no short form abbreviation for this. DYNE. Full form only you are supposed to write for CGS unit. Next, 1 kgf is equal to 1 gn. G is acceleration due to gravity, which is 9.8 meter per second. Go through this. So remembering this value is important. If they have not given the value as G is 9.8, you can directly take it as 10. You can round it off. It is acceptable from the both point of view. So let's move ahead further. Kinds of motion. So forces applied and motion is created. What are different kinds of motion which will be experienced when force is applied? Linear or translational motion, rotational motion. So let's see each of them in detail now. Linear motion or translational motion. So you can see here from A to B, it is moving along the straight line path. So which is considered as linear motion. So force is applied over here, it is moving in the same direction of the force applied. So let's see the definition. When force acts on a stationary body which is free to move, the body starts moving in a straight path in the direction of force applied. Similar to the image or the video which is playing towards the left hand side, A to B force is applied and the body is moving in the direction of the force applied in a straight path. Right. And so the example is pushing the ball lying on the floor begins to move. The ball is pushed from point A to point B. So it is begin to move. Go through it. Let's move ahead further. Rotational motion. You can see a wheel over here and it is rotating around its axis. So force is applied in this direction basically. So let's see what is rotational motion. If a body is pivoted at a point, what is pivoted? If it is fixed at a point, this point is known as pivoted point. You can see it is the body is fixed at this point and force is applied on the body at a certain point. You can see at this point force is applied. It rotates the body about the axis passing through the pivoted point. So this is the axis of rotation and it is rotating along the axis. Along the axis of rotation only it is rotating through the pivoted point itself. So this itself is known as turning effect of force of the body. So a wheel rotation about its center, that is the example which I have put, the video which is playing towards the left hand side is the same example, wheel rotating about its axis. Or similar way, fan, when force is applied, fan also rotates about its axis. It is pivoted to the ceiling. Right, go through this. Let's move ahead further. Moment of force or torque. So this moment of force is basically definition remains same and formula also remains same irrespective of the classes. Class 8, 9, 10, we have all learned the moment of force. In fact, this picture which I have taken is there in the 9th textbook as well as 8th textbook. So basically you have, if you people remember the concept and if you have old to that concept, it would be just a glance through this topic. Else you have to read it newly. So let's not waste time. Let's start with it. Moment of force or torque. The moment of force is equal to the product of force and the perpendicular distance of line of action of force from the axis of rotation. So the definition should be word to word. In ICSE, definitions should be word to word. If not, they are going to cut the marks. So key terms over here is product, magnitude of force, perpendicular distance, line of action of force, axis of rotation. All these words should be there. So what is magnitude of force? The amount of force. You can see the amount of force, and here there is a perpendicular distance between the line of action of force and its axis of rotation. OP is the axis of rotation and PA is the line of action of force. So there is 90-degree angle formed over here. So it is a perpendicular distance from the axis of rotation is known as moment of force. So this as well as this, if we multiply, we get moment of force. So turning effect of a body by a force depends upon two factors: magnitude of force applied and the distance of line of action of force from the axis of rotation. Basically, a magnitude of force that, as I told, it is the amount of force applied and perpendicular distance. It is not only distance, it is the perpendicular distance. If it is perpendicular, then only moment of force is possible. So the force which when applied at a point of a fixed body and rotates the body about the fixed point is called the turning force. So this is not called moment of force. If a force which is applied on the point of a fixed body and rotates the body about a fixed point, that is called turning force, not the moment of force. So please don't get confused with the moment of force and the turning force. Turning effect and moment of force is same. Turning force and moment of force is different. Hope you have got some clarity. The turning effect of the force acting on the body about the axis is called moment of force or torque. Turning effect is called a moment of force. And this moment of force is basically a vector quantity because it is depending upon the direction, perpendicular. So it is a vector quantity. And SI unit of moment of force is Newton meter, not joules. I specifically say not joules. So many give reasons might come. Why the SI unit of moment of force is Newton meter and not joules? Why? Because moment of force is a vector quantity. It is force into displacement. So it has a particular direction. So it is not joules, it is Newton meter. You are supposed to write in this way. So if they ask, or else comparison between joules and Newton meter. So joules, it is used for work. Work is equal to force into distance. So it is basically there is no direction over there, so it is a scalar quantity, so we can write joules. Here it is a vector quantity, so we cannot write joules, so it is clear for us. So CGS unit of moment of force is dyne centimeter. As I told, dyne, there is no abbreviation, you have to write dyne only, no just dy, no, only dyne, dyne, fully you have to write. Let's move ahead further. Anti-clockwise movements are taken positive and clockwise movements are taken negative. Why? We have it over here. So see over here, when force is applied in this direction, the rotation takes place in the same direction. So in anti-clockwise direction. So it will be taken positive movements. So if it moves in a clockwise direction, it is taken negative. There are more theories to prove all this. So for the ICSE 10th standard level, this much would be sufficient. Okay, they will not ask any provings basically. So for ICSE 10th standard level, so this much theory part. Anti-clockwise is positive, clockwise is negative. If we are aware of this, it is more than sufficient. Let's move ahead further. Moment of force or torque. Again, it's a continuation basically. So ways to change the direction of rotation. How to change the direction of rotation? By changing the point of application of force. By changing the point of application of force. By changing the direction of force. So these two are the two conditions or two ways how we can change the direction of force. Okay. Relationship between the units. 1 Newton meter is equal to 10 to the power of 9 into 10 to the power of 2 centimeter. Therefore, 1 Newton meter is 10 to the power of 7 9 centimeter. 1 kg F meter is equal to 9.8 Newton meter. So these are all basically standard derivations. So basically we cannot change any of them. We are supposed to write as it is and as such. Board also expects the same. 1 GF centimeter is equal to 980 dyne centimeter. You can either write it in Newton meter form or dyne centimeter form. So few examples are there. So amongst that, one of the example picture I have put over there, and I will explain using that picture now. Now, what are the examples? On opening, sorry, to open or shut the door, we use moment of force. So hinges, the perpendicular distance between the handle and the hinges, and the force which you apply it on the handle to open the door or shut the door is also a form of moment of force. Turning a steering wheel, again there is a perpendicular distance and the force is applied. So again it is a moment of force itself. Turning of a two-turned wheel of bicycle. So there is a perpendicular distance between the wheel and the chain, right? So there is a perpendicular distance, and for you to tilt the wheel, you are applying force over there. So again, it's a form of moment of force. Spanner used to loosen the nut. Here is a picture. See, force is applied over here, and there is a perpendicular distance between them. Loosening the nut, and over here there is a perpendicular distance. You can see a 90-degree angle is formed. So over here also moment of force is applicable. Let's move ahead further. Couple. Now, as we hear the word couple means anything two. Okay, couple means two. So you can see over here in the picture, there are two forces. One here, one here. So now, using this, we will derive the definition. When two forces acting on a body are equal, parallel and opposite but not along the same straight line. See, they are along the same straight line? No. They are equal? Yes. They are parallel? Yes. They are opposite? Yes. So, they constitute to form a couple and produce motion in it, motion in the body. So example is turning a steering wheel. So yeah, basically we use both our hands to turn the steering wheel. So when we are using both the hands, two forces are acting which are parallel to each other and they are opposite to each other and they both are equal but not along the same straight line. So we use over here. Turning a key in a lock, yes, we go like this and come back again in most of the locks and keys. Turning a screwdriver, etc. Which are pair of forces applied for rotation. So a pair of forces applied, so couple, that is. Moment of couple. Moment of couple is similar to the moment of force. The perpendicular distance between two forces is called couple arm. Not the moment of couple, it is called couple arm. The perpendicular distance between two forces is known as couple arm. So therefore moment of couple is equal to either forces. Either forces means two forces into the couple arm. Force into displacement, that will be basically. So hope you have understood all those concepts. If that is clear, equilibrium would be more easier. Equilibrium. So when they are balanced. Equilibrium means in chemistry also what we take is when they are balanced. When they come to a balanced state. So then it is equilibrium. Here also when they are in the balanced state. So let's see. When several forces acting on a body produces no change in the state of rest or linear or rotational motion, the body is said to be in equilibrium. The body is said to be in equilibrium. Okay, you have to be aware of the definitions and terms here are important are with several forces, no change in the state of rest or linear or rotational motion, body is said to be in equilibrium. So basically forces apply it and there is no change, then the body is in equilibrium. If you apply force on a wall, then there will not be any change, then it is said to be in equilibrium. Types of equilibrium. Static equilibrium. When several forces acting on a body produces no change in its state of rest, then basically here the body is in the state of rest and there will not be any change after the application of force as well. So book lying on a table, force is applied upon the book perpendicular to the book, so nothing will happen. It lies on the table itself. There will not be a single movement of molecule as well when the force is applied in a perpendicular direction to it. So basically, if they do not move, if they remain in the state of rest itself, then the body is said to be in static equilibrium. So similar way with the beam balance, holding weights, having equal forces on both the sides. We know in the meal balance, basically they put vegetables, fruits on one side, and another side weights will be added in order to make sure that the fruit is so much kg, so much grams with respect to groceries, all those things. Next type of equilibrium is dynamic equilibrium. Dynamic equilibrium means when force is applied on a body and the body is already in a motion. So there will not be any change in the body upon the application of force. So basically an aeroplane moving with a constant height when lifted up and balanced its weight downwards, you are sitting on an airplane and you are applying complete weight on the airplane, but it's not moving down. Why? Because the force is applied and there is a dynamic equilibrium taking place. Dynamic equilibrium is a condition where when force is applied on a body which is already in the motion, means which is already in moving, which is already moving, and upon the application of force also it continues to move. There will not be any change. So then the body is said to be in dynamic equilibrium. Hope it is clear now. Conditions for equilibrium. The resultant of all the forces acting on a body should be zero. This is the main condition. All the forces when you add clockwise, anti-clockwise, you should get zero. The algebraic sum of moments of forces on the body about the point of rotation is said to be zero. Basically, these two are similar kinds of point, but it is fine. You can apply both the points, both are applicable, both are apt, basically. So basically, the sum of moments of forces or sum of all the forces should be zero. The resultant of forces should be zero for the condition. Next, coming to the last part of this this video basically, principle of moments. What is the principle of moments? According to the principle of moment, this is a principle. So principle, statement, or law, anything, it should be as it is, including the definition. It should be as it is. You by heart, you understand whatever you do, but it should be as it is to the board point of view. Else, they will not be giving marks. No merciful marks will be given just because you have giving the same meaning, but there are no application of standard terms over there. Terms are very important in physics. So according to the principle of moments, you're supposed to write this according to the principle of moments. In an equilibrium, the sum of anti-clockwise moments is equal to the sum of clockwise moments. So this statement, completing, is important. Complete statement is a keyword. Complete statement is a keyword and completing is a principle of moments. So this principle of moments is such that I have kept a mean balance towards this right hand side, you can see. So if you add weights over here and if you add weights over here, they should be equal. So sum of these weights should be sum of these weights. Sum of the clockwise movement should be equal to sum of anti-clockwise or vice versa. So now we have an expression over here. Sum of anti-clockwise movements is equal to sum of clockwise movements. How to do that? Weight of the anti-clockwise movements and length of the anti-clockwise movement should be equal to the weight of the clockwise movement and the length of the clockwise movement. Basically, product of them. Weight of W1 L1 is equal to W2 L2. So weight into length is equal to weight into length. So this is basically moments. Moments means it is force. Force means weight. Weight is applied on the body. So force is also applied in turn. And length. Length is nothing but distance. Perpendicular distance. So basically, bringing out all the concepts, we have done this. Hope you liked this video. Please click on the thumbs up button and share this video. If you have any doubts or if you want to comment on this video, please mail me using the mail ID studywithakshay65@gmail.com. Next video will be coming with center of gravity, which is more interesting part. Stay with me till the end. Stay home, stay safe.